Hello, everyone. Welcome to another VMware code session. My name is Madhu Krishnarao, and today we'll be talking about the NSX-T Terraform policy modules and look at how you can deploy an entire three-tier topology, including routing, switching, firewall rules, configuring the virtual machines. You can do all of that using Terraform. So let's look at that. So a quick note on Terraform. It's, of course, an open source infrastructure as code tool. It's by HashiCorp. It's declarative in nature. It's cross-cloud. It's based on Go language. Of course, this is all just native Terraform features. But when we look at NSX-T, what NSX-T does is it creates a Terraform provider. It's developed by VMware. It's completely open source, but is also 100% supported by VMware. So you can still use it. If you have questions, you can always reach out to VMware for troubleshooting or any help. So the latest, the Terraform platform itself, the latest version is 0.12. And the provider version, the NSX-T provider version is 2.0. It's, of course, based on Golang SDK that we build automatically at every NSX build. It, of course, understands the underlying NSX-T infrastructure. It does the lifecycle maintenance of it. And yeah, it's the single point. It uses the SDK in the backend, which means it's the only point of contact with NSX-T. Again, a quick, I guess, a little bit deeper, brief, very, very brief intro on Terraform terminologies. So typically, you have three terms that you'll have to be familiar with: a provider, a data source, and a resource. So a provider is essentially what is managing the lifecycle, the connectivity, access to that system. Now, here it says in the example shown on the screen, you see it's provider NSX-T, which means it's an NSX-T provider. So you have the NSX-T's username, password, and connection parameters. A data source is how Terraform can read an existing object that is created outside of Terraform. And a resource is a component within the infrastructure that Terraform currently owns. It can create that object. It can edit that object. And you can also see that in the example on the screen, the transport zone is actually referencing a data source on the third line. So we'll actually look more about all these things when we look at the source code. As I said, so the main goal of today's session is to deploy a complete three-tier topology. The assumption is that you already have a tier 0 gateway, which provides your north-south connectivity. Maybe BGP is configured, maybe other static routes are configured. So Terraform has the ability to just connect to your tier 0 gateway. And then from an NSX-T perspective, what we need is a tier 1 gateway. It's another router. It can manage your services. It provides connectivity to other segments. And it's also a design that I just chose for this demonstration. So using Terraform, you can create your tier 1 gateway. And then, of course, for a three-tier topology, the topology is not complete without the three segments. I have one segment for web applications, one for app, the third for DB. Finally, I'm going to create a couple of groups, segments, and have DFW policies. Now, this is important because you want to protect your virtual machines the moment they come up. So I already have the DFW rules in place before I configure the VMs. Now, the good thing about using a Terraform as a platform to automate is you can seamlessly switch between different providers. Now, as I mentioned, NSX-T has its own provider, and so does vSphere. So when you want to configure a VM, so in my case, I do want to create a new VM, one for web, app, and DB. I want to change its network so that it's now connected to the segments that I just created. For all of that, I need to be able to talk to vSphere and automate that part. So we'll see how to do that. Finally, I'm also going to tag the VMs so that the dynamic groups within NSX-T can read the VMs, and then enforce your firewall policies. So let's quickly jump into the demo. Now, before I go into the demo, I wanted to show a few, the site, the terraform.io site. So as you see, you can just Google for it, or you can go to the terraform.io site, look at providers and NSX-T. It's fully documented. It has examples. It has good descriptions of how to do the connectivity, what various parameters that can be used. I will be talking more about these things when I go through the code, but if you just want to look at the URL, there it is. Now, in terms of getting Terraform itself, so we go to downloads in the same link, you will see that Terraform is available for a wide variety of platforms. Pick and choose whatever you want. In my case, my setup is Ubuntu virtual machine. So I picked up the 64-bit Linux Tarball. In my VM, I have already installed Terraform. So you could once you install it, I guess the first thing you can check is do a Terraform version. It tells me that the platform is version 0.12. That's the latest one. It also tells me that I am currently using two providers, one for NSX-T and one for vSphere. Now, if you are trying this out for the first time, and when you install Terraform and when you do a Terraform version command, you will not see the provider information. That's okay, because of course you don't have any config files in place. All of Terraform's configuration is essentially written in a .df file. So here you can see there is a main.df. If I open that, of course, you might have noticed a readme.md, which means all of this code is already on GitHub. I will show you the link for that too at the end. Now, if I kind of walk through what this script does, right? It of course creates your tier one. In my case, of course, I want my 3 segments, but I also want DHCP to be configured for the virtual machines that come up on that segment. So my Terraform code will also do it. It will create a bunch of groups with dynamic membership criteria. I say dynamic membership because when you tag a VM, NSX-T can figure that out. The group, the DFW rules uses groups, which is based on tags. We'll see how that works. I'm also using a couple of services like HTTP or MySQL services. I am creating NAT rules. This is specific to my environment. You can choose not to do these. Plus, of course, it's also going to tag the VMs so that the DFW rules can pick it. So as I mentioned in the slide before, the tier 1 gateway, we assume that it's pre-provisioned. Typically, your north-south gateway, your north-south router is already configured within your organization. So Terraform is just going to consume it. There are a couple of other NSX-T related system infrastructure that are needed. One is the transport zone and edge cluster. Of course, when you're deploying a router, you know that the routers do get deployed on the edges, especially when there are any services on it. Since we are deploying a DHCP server, I'm going to create an edge cluster and keep it ready. Towards the end, when I want to create a new VM, I'm going to clone from an existing template in my case. So I have that VM template available in vSphere as well. It, of course, uses the 3 HTTP, MySQL, and HSS services that are inbuilt within NSX-T. Now, a quick look at what I just mentioned, right? So you have your NSX-T environment. If you go under System Nodes, you can see I have an edge node and an edge cluster defined. If I go look at my vSphere environment, I have 2 clusters, 1 host each. This is just my lab environment. There are no virtual machines on this. However, I do have a template available. If I go under networking, all I'll see is a distributed switch. You're all familiar with the vSphere distributed switch. So I just have one of those and everything all set for Terraform to consume. Now, walking through the code a little bit more, right? The first, of course, is how you can connect to NSX. That's what the provider tells you to do. So this is my IP address, username, password, whether I want unverified SSL because mine is a self-signed cert, I've set it to true. Number of retries, NSX-T returns 429 if the server is overloaded when you're making too many API calls. So I have a retry on 429 written code. Terraform as a language, as a declarative language, also lets you create variables. Although in my example, I have mostly hard-coded strings, but you could use a variable in this format. Now, this is very Terraform specific. You can choose to define all your variables in the same file, or you can choose to define a variable in a separate file and just include it here. The choice is entirely up to you. Now, now that we are starting with a tier 0 deployment, as I mentioned, we do want to create a few data sources to consume the existing edge cluster, the transport zone, and the tier 0 gateway. So all I have to do from a Terraform perspective is define a data source. This is the name of the data source as defined in our provider. The name, which I'm going to use to refer to this specific data source within this script. The scope of this name is only within this script. And this is the actual object it refers to on NSX-T. Similarly, I have for transport zones, a tier 0 gateway that is already pre-configured on my NSX-T. So the first thing I want to do is, of course, I want to define a tier 0 gateway, but I also want to define a DHCP service. So I'm going to say a central DHCP server that's going to be sitting on my tier 0 gateway. Let's say that's my topology. So from a Terraform perspective, when you want to convert that requirement into source code, it's extremely straightforward. You just define your resource, which is your tier 1 gateway, give it any name that you want. These are all different parameters that this specific object takes. Now, explanation of what these parameters are, whether they're applicable in your environment, the best way would be to actually look at the Terraform documentation available here. So if I go to the same resources, to the policy tier 1 gateway, you can see that it explains what each of those fields are, what are optional, what are mandatory. You can select them, you can give the right variables, you can use the right data based on your environment. But here you can see that because I want to configure my DHCP server, I am referring to the resource that I just created. Now, I could have written this block of code anywhere else in the file. Terraform is good with figuring out the dependencies, so you don't have to worry too much about it. There is also ways to explicitly define a dependency. I will talk about that because I'm using that in my code as well. All right, so continuing with that, I want to, as a general principle, right, NSX-T allows you to tag almost any object within its domain. So it could be your tier 1s, it could be your virtual machines, it could be firewall rules. So as a general principle, what I do is tag all of the resources that my scripts are creating. That way, when I go to NSX, it's extremely easy for me to search for a specific object based on the tag. Plus, I will also know how many objects my scripts created. It will also help me differentiate between objects created through my script versus either some other script or through the UI itself. So in this case, I am tagging all of my objects created through Terraform using the tag and the scope defined above. I have a few without advertisement rules. Again, this is specific to my environment. You're free to copy it out, copy and modify that and try it out. But yeah, make sure it conforms to your environment. And then comes my segment. So of course, now that we talked about the first tier 0 gateway, I now want to create 3 of my segments. So the first segment, I just call it a web tier. You can see that I am saying this specific segment has to be connected to the tier 1 gateway that I just defined above. Similarly, I'm also saying this segment will use overlay transport zone, which I had defined above. Now notice the difference between how I'm referencing a data source versus a resource. Just a Terraform syntax nuance. This is my subnet information for this segment, nothing special about it. Advanced configuration, I want to make sure the segment is connected the moment I create it. And I also explicitly tag, you can have multiple tags on this object. So I'm explicitly tagging this as a web tier, whereas I'm also using the default Terraform tag for the object. Again, this is to just showcase that you can use the tag object multiple times. Similarly, I'm creating a app segment. The format looks very similar. You can define your connectivity path. Again, it's connected to the same tier 1 gateway. It uses the same overlay segment and defines another CIDR for your app segment. I have tags and the third segment as well. It's defined in exactly the same way. A few of the parameters change. The next is I'm jumping into creating different groups. I mentioned I want to create different dynamic groups so that I can use them in my firewall rules. So I have a group that encompasses all of the VMs. This is just so that if I want to search for it, or if I want to enable certain DFW rules common to all VMs, it just gets easier this way. Then I'm grouping all my VMs with the tag web as a web group. This is how I am going to differentiate a web VM versus an app VM. Plus, because I'm basing this on a tag, so tomorrow, if you, let's say, you have a lot of load to your web server and you want to scale it out, you create a few more web servers. All you have to do is tag it. You don't have to change your firewall rule. NSX-T will be smart enough to figure out that there are new workloads that needs protection. This is exactly what a dynamic group membership does. It creates a few more groups, one for app, one for DB. And again, as an example, these were dynamic groups based on tags, because the members for these groups are generated at runtime in a sense. Whereas you can also create static groups or groups with static members. In this case, I'm creating an IP set with a bunch of static IPs. Maybe I want to use these as external connectivity for external systems. Maybe I want to allow connections from only these external IPs into my applications. So just based on that, you can define it. Then I start creating services. Again, DFW rules can use services. Of course, it's a full-fledged L4 to L7 firewall. So you can use services. So I'm starting with a specific custom service. It's a TCP connection on port 8443. So I want to define it that way. But as you can see, because I'm defining this service, it's a resource. However, I also want to use an existing HTTPS service. So I'm going to use the data source for it. I don't have to define this. NSX-T already has it. And because I want to consume this through Terraform, I'm going to kind of refer to it as a data source within my source code. All right, so all of my objects are created. Now I'm going to actually create my firewall rule. Now it looks complex, but it's not. Once this translates to what you see in the UI, which I'll show in a minute, you will see that this is just writing everything out in a very simple declarative way. You don't have to worry about the underlying Go language syntax. You don't have to worry about any API calls. As a user, as a consumer, you just give a bunch of name value pairs, and Terraform helps you do the rest. So here I'm creating one section with a specific set of attributes. Then I'm creating a bunch of rules. I'm creating a rule to allow HTTP traffic. I'm creating a rule to allow SSH, connections between web and app and DB. Again, this is more of an example of how you can define your rules. Of course, you'll have to change it and massage it to meet your explicit needs. But yeah, it kind of gives you a starting point for it. Plus, I have a simple rule that also lets every virtual machine ping each other. I'll come back to this rule again later. Finally, I have a deny all rule. So it's more of a whitelist, and the default is reject. Along with that, I decided to have NAT rules in place on my tier 1. So I have created a bunch of NAT rules. Again, the definition is pretty straightforward. What each of these variables mean, what attributes are there, what other options are available are all extremely well documented on the site. You just take a look. So I'm creating, I think, 4 NAT rules. This, in theory, kind of completes my entire topology that are required to support a 3-tier app. So I have routing in place, I have switching in place, and I have firewall security with dynamic memberships and services in place. Now, what about the rest of the code, right? When you're dealing with NSX-T 2.4 and above, or of course I'm going to run this with NSX-T 3.0. We have a policy layer, and then we have the imperative object layer, the old MP APIs as we call it. You want to make sure that whatever you define in the policy layer is actually realized. Now, if you're looking at the UI, that's straightforward. You can make sure the object is available, make sure the connectivity is green. There is an implicit way you're actually waiting for confirmation. But when you're automating, it's extremely important to do the same. You have to automate validation as well. That's very, very important. So what I have done, of course, there are other ways to do it, but what I have done with this specific example and these policy objects is that once I create the object, once I created the segment on the top, I want to make sure the segment has been realized. Now, why do I want to do this? As I mentioned, with the same script, I want to talk to both NSX-T and vSphere. I want to create the segment and immediately create a new virtual machine that's going to consume this, and then that's going to attach to this specific segment. So when I want to do that, I want to make sure, of course, segment is realized completely. So what I'm doing here is I am using a data source. It's for the segment realization. Again, I'm just naming it. And I'm saying that, hey, this is depending on the segment that I just created. Similarly, I'm doing for the web app. I'm also getting some information. This is, again, as an example. You don't, if you look at my GitHub repo, I'm not using this anywhere. I've just put it as an example. All right, that kind of concludes the NSX-T part of it. Now, before I jump into the vSphere part, I just want to kind of run this script because it is going to take about 3 minutes or so because I am cloning 3 VMs. It has to power on, it has to get address from DHCP. So it's going to take a few seconds here and there. So I want to kind of start the script and come back and talk more about what I do next. So let's say if you look at where we left off in terms of setting up your environment, you just downloaded your Terraform environment and you did a Terraform version to make sure everything was up to date. Now you went to GitHub and you got this source code, which is main.tf, checked out. Great. So what's next? The first thing you can do And you have to do for the very first time is do a Terraform init. Now, what this does is it scans through your config file in the current folder. It'll figure out what providers are needed. It will install it automatically for you. So you as a consumer don't have to worry about, oh, how do I get the NSX-T provider, or how do I get the vSphere provider, or any other provider for that matter. Just use it in your script or in your config file and do a Terraform init. And of course, you can do it multiple times. If there isn't any update needed, it'll automatically update it for you. If not, it'll just quickly scan through it, tell you everything is good. Now, Terraform as a platform also gives you another important thing, which is probably one of my favorite things about Terraform. It gives you the ability to look at your plan. Now, looking at the source code is one thing, but looking at exactly what objects are getting created is also interesting. So you can do a Terraform plan. It's going to scan through your config file, figure out what dependencies are there. It'll figure out what objects have to be created, what objects have to be deleted, if any, what objects have to be modified. So it'll do all the hard work for you. It'll give it to you in a very nice format. In this case, because I'm creating this for the very first time, all the objects have a green plus on it. If there are any edits, it'll actually show you in a different way. And I'll show that in a short while. So now that I have kind of went through my plan, I know that this is exactly what I want to do. To apply this plan, all I do is, as the term says, apply. Now I can press enter. It's going to go through the plan, and then it's going to ask for confirmation again. But if I don't want to wait for that confirmation, and if you're kind of scripting this out, if you kind of want to do a one button install for everything, you could do this. You can just do auto approve. So which means that the yes, the accept is implicit. This is almost like doing a yum install minus y, just as an equivalent. So the objects are refreshed. So Terraform maintains a local state machine. It looks at all the config files. It looks at objects that it has to read as a data source, and then it builds its own local state machine, which means that it kind of compares everything to that state machine. So that's what it's doing right now. And then once it finishes that, it starts creating the objects, one depending upon the order. Now, I will also show how the order, how it figures out the order towards the end, but that's more of Terraform internals. So now you see it's already finished creating all of the NSX-T components. You can see that it's started to create my 3 VMs. So let's jump to vCenter and see what it's doing. So this is my vCenter environment. Let me bring this up a bit. You can see the cloning is still going on. If you noticed, before we only had the distributed switch. Because vCenter is integrated or is registered with NSX-T, every time a new segment comes up in NSX-T, the corresponding DVPG or the port group is created in NSX or in vSphere, sorry. And in my case, I'm using the latest NSX 3.0 and vSphere 7.0 with the VDS 7. So the segment, the logical switch that it creates comes up as a regular distributed port group. It's no longer an opaque network. If I go look at my VMs, you can see the 3 VMs are being created using the base template. Looks like one of the VMs is already getting powered on. The other 2 are still waiting to be powered on. Now, if I come back and look at NSX-T, so the first thing that we asked Terraform to do was create a tier 0 gateway. Sorry, a tier 1 gateway. So this is the one that got created. Of course, the 3 segments app web and DB are already created and configured with the right CIDRs and DHCP ranges. You will also see that all the dynamic groups that I wanted have been defined. You can, of course, look at members, which I'll show as well. But before that, I want to show the firewalls. So remember, we created a distributed firewall with a bunch of rules. So this is where it is, and this is how it looks. So each of the specific rules can also be enabled, disabled. You can control this through Terraform, and I will actually do that for the ICMP rule. It also creates the default gateway firewall on the tier 1 router that I just created. In my case, because everything is controlled through through DFW, and I'm not doing anything at the north-south connectivity layer, I just have any allow for now. All right, going back to the code. So while we wait for, oh, there we go. The VMs are created. And if you noticed here, the tags were also applied, which means if we go back to NSX-T, look at virtual machines, you see that each of these 3 virtual machines are already recognized by NSX-T. It has 2 different tags. One is the generic demo tag that I have. The second one is my web tag, which helps with DFW rule, which means if I go under groups and look at web VMs and look at members, you can see that my virtual machine is already part of that group. I didn't have to explicitly add this. If I remove the tag from the virtual machine, the membership here goes away. If I add it back, of course, or if I add more VMs with the same tag, you will see all of the information here. So now the topology is ready. The VMs have been created. They've been powered on. And more importantly, let's check if the IP address has been assigned through the DHCP. So simple vSphere operation, go look at the console. Let's see if I gave the password right. Nope. All right. And yep, it's got an IP address of 12.12.1.101 from the pool that I defined. So at this point, let me check what the IP for any other VM is. So for this app VM, it's 12.12.2.100. So let me ping that. Uh, 2.100, sorry about that. All right, so the VMs can, of course, ping each other. And what I'll do is let the ping happen. I will go back to my Terraform config file and make some edits. Now, of course, Terraform is not just good for creating objects. It can also manage your objects, which means that you can come back, edit objects, modify it. So in my case, I will look at my ICMP rule, and I'm going to disable it. So that's it. I didn't do anything else. So now I'm going to do my apply again. Now, as a user, I don't have to worry about other objects that were created. Terraform is smart enough to figure out that what changes needs to happen. But this time, I'm not going to auto approve. I'm just going to do an apply because I want to see what exactly Terraform did in terms of making a plan and looking at the difference between the 2 configs, what was existing and what, based on what changes I made. All right, so before I do, yes, it says there are 7 to change. It's because some of the IDs are generated by at runtime, so it thinks they might need to be updated. But if you can see, the pluses are all gone. There is a kind of a tilde mark, which tells that these objects have to be modified. And if I can go look at my DFW rule, allow, right here, you can see that the false is being changed to true for this specific attribute. So I type yes, because yes, of course, I know I did the change. I want that to happen, and done. So if I go back, you can see the pings have stopped working. Let me kill the ping. The pings stopped working because if I go back to DFW rule, the specific ICMP rule is now disabled. So the default rule of reject is hitting for ICMP packets, and it's getting rejected. So yeah, that was extremely easy way to deploy your entire 3-tier topology using NSX-T Provider and vSphere Provider. So now let me go back. I know I said I'm going to come back to the vSphere Provider, which I'll do. Approximately that line number. All right. So till this point, it was all NSX-T Provider information. Now that you kind of saw NSX-T Provider, you will also see that the provider for vSphere is something similar. You give the username, passwords, the connectivity type. And here, because I'm dealing with virtual machines, if I want to create a virtual machine in vSphere, of course, I need to tell vSphere which data center to use, which cluster to use, which data store to use, and which host to put it on. And all of this information is the inventory is already there in vSphere. And if Terraform wants to know about it, of course, you have to do a data source for it. So here is all the data sources for the data centers. You will also see ones for cluster and data store down below. The second thing is when you create a VM, you of course want to attach it to the segment that you just created. You want to attach the web VM to the web segment, app VM to the app segment. So to use those segments, I need to be able to include the segments that vSphere sees as a data source. Because the moment NSX-T created the segments, those segments appear in vSphere as distributed port groups. We saw that in the UI. From a Terraform script perspective, these objects are still distributed port groups, DVPGs. So they will be referenced as vSphere network. So there is a default vSphere network module. The name of it, this is the name of the object in my inventory. This is the data center in which that object will be found. And this is the resource it depends on. Now, why exactly did I do this? Because of that implicit dependency. Remember, if you're doing it through the UI, you know that when you create a segment, you kind of wait for a screen refresh or look for a green confirmation dot in the UI. Now with scripts, that's hard to do. This is true for any sort of automation. So you want to make sure that your automation that you're building is can deal with such kind of validations. It has to do validations in between and either pause or exit if the validation does not succeed. So I have the data sources for my vSphere network, which is my web app and DVPGs, a bunch of other data sources for my clusters, for my 2 clusters, for my different data stores that I have, and for my template. Now that I had defined all of it, I am going to clone a virtual machine using the vSphere virtual machine resource. I am going to give it the template UUID, which I just defined before. And the most important one, the network here. Again, as you see, I am not referencing the NSX resource, NSX segment resource, but I am referencing or referring to the vSphere network itself. Once the VM is created, I, of course, want to tag it because that's how it gets included in the group membership. So I'm doing that. And I'm repeating this operation for my other VMs. Once I, of course, to tag it, I want to make sure that VM is available as an inventory in NSX-T. So I use a data source and then use that instance in my tagging. Similarly, for the app VM, I clone the app VM, then I tag it. And for DB, for the database VM. That's it. The script is now that you kind of walk through it, it's fairly straightforward. I know I said it's already available on GitHub. So let's look at that. So there you go. You can come back to this anytime you want. Feel free to fork it, contribute back to it. This is just my example for this specific demo. Now that said, I also said the entire NSX-T Terraform provider is open source, and it's supported, which means you can also contribute to it. So, of course, this is the official place from where you can get it. When I say official, it's because when we develop the NSX-T Terraform provider, we also get it certified through HashiCorp so that it's available in terraform.io site, which means you can do a Terraform init and install it. Now, what if you want the latest bleeding edge code? What if you want to contribute something, or you want to just check out what our engineers are working on? So that's easy. Go to the official Terraform providers NSX-T repo page. This is public. Anyone can fork this. Anyone can contribute back to this. If you have, because this is open source, we run it like an open source project. If you find any issues, just file an issue on GitHub. All of us from the project management team, engineering, we are very active on this repo. We do look at it, we do respond to it. You can also file your feature requests through GitHub if you want to. And we'll be more than happy to accept pull requests. So if you think there is a small change that you want to contribute back, you want to add to the examples, please feel free to do it. Just send in a pull request. We will look at it, approve it, and when the next release happens, it'll be part of the main upstream code. So that'll be good. Now, the GitHub repository also has information about compiling from the source. Now, of course, the automated installation using the Terraform init is the recommended preferred way if you don't want to deal with any code compilation. But if you want to look at the latest code, if you want to just play around with it, you can. You can just download it, do a make command. The instructions are all on GitHub. This will give you a binary. You place it in the right folder, which is explained in the document. Now, I've already done this process on my setup. So I'll go to that folder. So here is my provider that I compiled from my sources. Now, in this case, if I can do a Terraform version, and I want to show the difference between what we saw before and what we see now. And I'm doing sudo in my case because I kept it in the root folder. If you have it somewhere else in your local user folders, you don't need sudo. Okay, so you can still see it's the latest Terraform platform. However, the NSX-T comes up as unrevisioned because this is your local compiled version. You can also notice that the vSphere provider that I'm using here is a dot version old, because if I go back and do the version again, you can see this is version 1.8. So this is just Terraform letting you play with different versions just by changing your directory in a way, but it essentially comes down to which Terraform binary you're using. Now, that's not all Terraform can do. Now that we created a bunch of objects using Terraform, right? You can, of course, delete everything using Terraform destroy. I won't do that right now, but what I'll do is do a Terraform show. What this does is give you a dump of your entire topology or your entire config. It'll just show you what Terraform sees in its state. So it's another good way of keeping track of things. If you want to validate this, do a diff against something else from a previous version, probably a good way to do this. Now, the other pretty cool internal kind of small feature with Terraform is looking at its dependency structures. So for that, let me make sure I get the right command. All right. There is a command called Terraform graph. It essentially gives you everything in a dot format. You can, of course, convert that into a PNG file. Happens pretty quick. And let me actually show you how this looks. Of course. All right, so let me get out of the full screen mode here for a second. Go up here. Desktop and the file that I just copied over. So this is the graph that Terraform sees. It looks complex, but when you start looking at it, when you start to analyze it, you know that it's essentially building this based on your config file. So we know that we are using Terraform provide the vSphere provider. Of course, it needs your data center, clusters. It will have your web DVPG. Now this DVPG will also depend on the NSX-T policy segment web, which is of course created by the NSX-T provider. So it's kind of interesting to look at this as well. All right, that was it. Thank you for spending some time on this. I hope you play around with Terraform. I hope you look at NSX-T, use this for your automation, and we'll be more than happy if you contribute back. We highly encourage contributions from the field. Thank you.